Lesson 15, video 2. Now we're going to look at some of the examples that have to work with these inverse trig functions. Okay? Just like we did before with that sine inverse of sine or sine of sine inverse, we're going to do the same kind of characteristics with these problems. For this particular problem, which I didn't leave myself enough room, I am going to take the tangent of both sides. Because I know by taking the tangent of both sides where there's an inverse function involved, this side will have tangent and tangent inverse cancel each other out. Again, it's like taking the square root of both sides where one side is squared. Again, it's similar to saying, well, if I have y equals x squared, let me take the square root of both sides. Okay, that will eliminate the squared term. I'll have x is equal to the square root of y. It's very similar to that, only now I'm more looking at the inverse function, simply saying I'm tangent inverse. Okay, so now I have the tangent of y is equal to radical 3 over 3. Again, these two things cancel each other out. Now the question you got to ask yourself is, when does the tangent of y equal radical 3 over 3? Okay, again, when does the tangent of y equal radical 3 over 3? Well, for me to answer that question, I'm going to go actually backwards with this. I'm going to say that this is actually 1 over radical 3. Okay, which is the same thing as saying I have 1/2 over radical 3 over 2. Yes, I do work backwards like this in my mind. Why? Because I only work in terms of sine and cosine, and once again, that unit circle. Okay, so where on the unit circle do I have this thing being sine over cosine? And sine being 1/2 and cosine being radical 3 over 2. On my unit circle, I'm going to have 1/2 increasing, 1/2, then radical 2 over 2, then radical 3 over 2. Okay, so that means I'm looking at this one right here. Again, where my sine is 1/2 and my cosine is radical 3 over 2. And this is the only point on the entire unit circle, because every other point is going to be negative, negative, positive, positive, or so on and so forth. Now, that doesn't mean that I can't have both of these negative, right? I would still make tangent positive. So I could be down here. There's a stipulation with that, okay? And yes, it does technically work, because the tangent inverse function can go on forever, just the way it's set up. Okay, I did not go through the graph of that particular function, but if I look at the tangent graph, we see this between what two values? Well, this is pi over 2, and this is negative pi over 2. Okay, so where is this? This is particularly at pi over 6. Okay, how does this look in terms of its inverse? If I actually reflect it appropriately, it looks something like this. Okay, where this up here is pi over 2, and this down here is negative pi over 2. And again, those would be asymptotes going horizontally now, where I don't cross. So this right here would be the graph of tangent inverse of x. Okay, again, moving from here to here is that transition, this being tangent of x, this being tangent inverse. So that refers to the fact that my y value, the thing inside tangent, must be pi over 6 for this to occur. It's pi over 6, or what other possible value? The occurrence of it down here. Well, pi over 6, I'm going to have 1, 2, 3, 4, 5, 6. It would be 7 pi over 6. But the issue for that would be the fact that at 7 pi over 6, I'd be sitting somewhere up here. And that's not working in this range that I want to be working in. Okay? So pi over 6 is the value that I'm looking for. Let's continue this problem on. Okay, let's go ahead and do 8b. 8b is y is equal to the cosine inverse of negative radical 2 over 2. Well, I hope you're very instinctually going towards the unit circle, saying, well, I have positive radical 2 over 2 there for x. There's a negative radical 2 over 2, and here's another negative radical 2 over 2. So it's going to be either here or here. Like I said, instinctually you're going straight to the unit circle. If you're not seeing that, maybe it might be safest to take your cosine of both sides first. Okay, by taking the cosine of both sides first, these cosine and inverse cancel each other out. I'm left with when does the cosine of y equal radical 2 over 2? Again, if you know your unit circle, you know your inverse trig functions. I'm asking you, what is the angle now? What is the angle now, not this value? So, when does that occur? It occurs here and here. This is going to be pi over 4, 2, this is 3 pi over 4, 4, this is 5 pi over 4. So it's one of those two, 3 pi over 4 or 5 pi over 4. But if you recall from our last defined problem that, and I'm going to go ahead and pull it up here, cosine inverse is only defined between, in terms of returning values, 0 and pi. Again, this is on your first page of lesson 15. Your cosine inverse function in terms of the values it returns is only defined between 0 and pi. That means this thing right here, okay, this cosine inverse of radical 2 over 2, it has to be between 0 and pi. And this is out of that range. So our answer must be 3 pi over 4. That completes problem 8 on this particular section. I'm going to go ahead and scroll in the next set of information. This entire table I want you to fill in from your textbook. Okay, it covers all the stipulations of all the trig functions that you'll have to be working with. I'm going to take a look at it myself, and again I'm going to redefine the fact that this is the inverse values, the inverse graphs, all of the information that you're going to want to know for all of the inverse trig functions. Okay, pay very close attention to what you have there. Likewise, scanning down here, these identities down here are also relative to the information that we have. It should make logical sense for these situations to occur. Okay, if they don't, again, ask me in class to explain those details. Lastly, on this video, I'm going to go through this piece of information, and the third video will actually go through all the examples. Okay, composition of trig functions. Now again, we'd like to think that sine and sine inverse will always cancel each other out and give me x. We would like to assume that cosine and cosine inverse will always cancel out and give me x in return. However, this is only true for the set of x values that I can plug in. If I can't plug an x value into here, the inverse function doesn't take it in. That means that the inverse function will not spit something back out, which means that the sine function will not take that in. Okay, I'm going to repeat that one more time. Watch this video if you don't catch it. The only set of x values for the inverse functions that I can plug in are between -1 and 1. If there's a different value in here, what am I going to call this thing? It's going to be called undefined. Okay, again, if a number in here is not between -1 and 1, I cannot define the sine inverse of that value. It is undefined. Okay, tangent, however, is very nice. Tangent of tangent inverse of x is always 100% of the time equal to x. Okay. Now, if I reverse which one comes first, notice these problems up here is sine of sine inverse, cosine of cosine inverse. These ones down here are sine inverse of sine, cosine inverse of cosine. When are those true? Well, again, thinking of the domain of values for the original trig function that I can pick, so that when I plug those in, I'm only going to get a value between -1 and 1. Again, the -1 and 1 must be what plugs into the sine inverse. What values will that work for? This set of values right here. Okay, so when I plug that in, it's going to take that in, and it's going to spit back that exact same value. This is only true for sine between -pi over 2 and pi over 2, where the graph is defined for sine inverse. Likewise, between 0 and pi, cosine inverse of cosine is defined. Again, where the graph of cosine inverse is defined. Lastly, tangent inverse of tangent is defined between -pi over 2 and pi over 2. Keep in mind, okay, think about this very carefully. The inverse trig function will spit back an angle measure. The inverse trig function will spit back an angle measure. If that's what it's doing, that means that the trig function, the sine here, will be pulling in an angle measure, spitting back a number. The sine inverse function actually takes in that number and spits back an angle measure. Rewatch this video if that's not making any sense. Again, inverse functions take in numbers, spit back angle measures. Trig functions take in angle measures and spit back numbers. So that will hopefully help you identify that sine, the y value, is -1 to 1. So the inverse sine function is going to have a domain of -1 to 1. It's swapping the domain with the range. Okay? Keep that in mind. In the next video, we're going to look at these particular values, okay? All of 11 through A through F, as well as 12 A and B, and then we'll talk about the equations.